So think, aids in thinking about serious... Waiting around. So people have told me that 2 minutes compiles aren't really that bad. So I figured that we should give them the freedom to waste their time. Wait, so essentially it's just waiting. It's literally waiting right now, right? So it's literally waiting. So it gives oh yeah. Bro, it's spinning up my freaking CPU right now. Oh my god. Freaking, it is really spinning on one of my freaking cores. Fuck you. Alright chat, wake up. The time has come to do yet another low effort slope. Recently I actually found this very interesting thing, which is an alternative to LLVM. And I found it by actually exploring C3 source code. Right, so at some point I looked into C3 and I noticed that it has an alternative backend, right? So originally it uses LLVM as its backend, right? And then I noticed like an alternative backend. I wonder if I can actually find it. So I think the backend is called TB or something like that. I wonder if I can find it. So there's a code gen, but maybe I have to fetch the latest changes. Okay, so let's actually fetch the latest thing, just in case. Tuberculosis. Is that what it stands for? Right, probably. I don't fucking know. And maybe we can grab backend. I already don't quite... Okay, so there is a code gen, right? So there's a SSC compiler, and there is a code gen. So where is the code gen? So there is a C code gen, and there is a ASM code gen, and there was, I think, tilde. I hope learner didn't actually remove that. It could be actually the case that learner removed it, but it was there, trust me. So maybe he experimented with something like that, or maybe he created a separate branch. I don't quite remember. So C branch, additional code gen. I think that's what it is. I think that's what it is. It's just this specific branch. I wish I could just switch to it. So additional code gen. So yeah, there we go. So backend TB. I started looking into that and I found this thing, right? So apparently it is related to that. So let's actually read about it. Tilde, my LLVM alternative. I'm Yasin and I hope I pronounced name correctly, so I'm sorry if I didn't. And I've made it my mission to produce an alternative to LLVM, the current king of compiler backends libraries. I'm calling it tilde or TB for tilde backend. And the reasons are pretty simple. I believe it's far too slow at compiling and far too big to be fixed from the inside. It is true, right? So nobody at this point really compiles LLVM themselves, right? So even when I needed to build C3, I think I just like downloaded LLVM from the official website, or on Void, I just installed it from the repos, right? It's kind of like a very heavy dependency. It is insanely heavy dependency. So it's been 20 years and Craft has built up time for a redo. As a test case, I wrote a C compiler and early tests show the preprocessor to be around 2 times faster than Clang's along preprocessor. Isn't preprocessor right? Not related to the backend. It's just like a very much front-end thing. But anyway, so it's 2 times faster than Clang's, along with being able to parse parse multiple translation units in the same process without threading issues and out of the order declarations. So to clarify, my project isn't some API compatible replacement to LLVM. It's just another backend that believes in a similar vision to early LLVM. And here is apparently the vision of the early LLVM. The world needs better compiler tools. Tools which are built as libraries. This design point allows reuse of the tools in new and novel ways. However, building the tools as libraries isn't enough. They must have clear APIs. I just instantly remember the clip of Jonathan Blow looking at the documentation, Doxygen generated documentation of LLVM. It's just like, they must have clear APIs. It's a fucking mess. Anyway, as decoupled from each other as possible and easy to modify extent. This requires clean layering, decent design, and avoiding tying the libraries to a specific use. Oh yeah, did I mention that we want a resultant libraries to be as fast as possible? Well, yeah, Chris Lander 2007, right? So where's my 2007? So apparently, yeah, I agree with that. If this was original vision of LLVM, it diverged quite a bit from it, honestly. Like by looking at this vision, you wouldn't think about LLVM. Like, would you think about it? This is not LLVM. What the fuck are you even talking about? Right. So that's pretty cool. That's pretty cool to go back to original vision of LLVM. I really respect that. So key features. Sea of Nodes IR, opposite to LLVM or GCC's SSA CFG. I have no idea what is Sea of Nodes. What is Sea of Nodes? Like, I never heard that term before, so let's actually Google it up. So what I like about this project as well is that it uses a lot of interesting terms that I never heard before. So that means maybe I can learn something, right? Sea of Nodes is a graph representation of a single static assignment. Opposite to SSA CFG. Oh, so opposite to SSA CFG. So there are different kinds of SSA, right? Single static assignment. So one of them is Sea of Nodes and another one CFG. Right. Forest of instructions. SSA. What is CFG though? Let me see. So it doesn't really tell us. Control flow graph. Right. So we have Sea of Nodes and control flow graph. All right. So and Sea of Nodes that combines data flow and control flow and relaxes the control flow from total order to partial order, keeping only the ordering required by data flow. Thank you, Wikipedia. Very cool. Anyway, let's put that on the back burner. Maybe we'll understand it later. Simple type system. Okay, so that's interesting. Fast compile times. Thread-safe modules can generate and compile to function at the same time. That's already impressive. It's almost like GI compiler. Code view debug and fall. Windows debuggers will handle it just fine. Capable of both JITting and IoT, there is also early works on directly outputting linked executables, thus bypassing the need for a conventional linker. Okay, so in progress. Currently, I'm working with Gingerbill on integrating with Odin. Oh, so not only C3 uses that, so Odin uses that as well. I think I remember somebody told me that. Yeah, it is used in Odin. So along with Sean Soma on MiniVM. So what is MiniVM? Let me see. So I'm using Web Archive because I'm in a very stupid country that bans website left and right. So this is apparently a different branch that probably doesn't exist anymore. So I really want to see what is MiniVM. So it's a VM that is dynamic and fast. But isn't language backend already basically a VM, isn't it? Unless it's a VM of like an existing machine, right? So it's a VM implemented using another VM, right? And by the way, this is the reason why LLVM is called LLVM, low-level virtual machine, because backends are basically virtual machines, aren't they? So, yeah. So it's used for JIT. I see. Very interesting. It has just-in-time compiler based on... Okay. That explains why you need this kind of stuff. Cool. All right. So I'm happy to self-host Quick. So Quick, if I understood correctly, is the essentially C compiler, right? So written using that specific backend. I'm hoping to self-host Quick this year, which will be the most capable example of TB. Along with this, the optimizer is in progress and going good with most of the expected optimizations, SSI construction, SSSV, folding, GVN, and code motion and stuff like that. All right, so that's pretty cool. Let's take a look at it. Right, so let's take a look at it. Here is the GitHub repo. And yeah, so obviously I probably want to get rid of the web archive. We don't really need it in here. So we only used it as a proxy. Right, already had it open apparently. Okay, so there's some third-party dependencies, so that means we'll have to probably clone it recursively. Let's quickly do that. So git clone recursive. Let's fucking go, meine Freunde. 1,000 commits, almost 2,000 commits. Okay, so I hope it's not gonna take too much time to download. That's a lot of megabytes. A lot of megabytes. And I suppose it's it's already done. Look at that. Quick. How do I? Oh. Oh. Well, that's pretty based. I mean, does it vendor its own Lua or something like that? Right, so if I try to find maybe a file, or maybe just like anything with the name that contains Lua, does it vendor it? Nah, it doesn't. You know what would be even more based? If like the Lua source code was actually part of the project, right? So then you would need only C compiler to just build everything. With the C compiler, you just build Lua interpreter, and then with the Lua interpreter, you run the build script. Right, you don't need anything except C compiler. That would have been based, honestly. Right, even though Lua source code is rather simple, right? So, like, it's insanely simple. So let me actually show you Lua source code, and you can pretty much make it part of your project if you want to. Maybe it is a little bit overkill. Who distributes source code like that? What the fuck am I even looking at? Lua, are you okay? Like, what the fuck is this shit? Excuse me. Yeah, downloads. This is what I was. This is what I wanted. Do I even have Lua in here? Maybe not. So let's double get this entire thing. Right, and then if I go here, for instance, right, then I just do make G16 and just time it. So yeah, there we go. I already built it. So I just built it in 1.7 seconds, the entirety of the source code. Right. So and the amount of the files in here is just pretty much this. This is the amount of files in Lua. This is the entirety of the Lua interpreter. Seriously. This is the entirety of it. That's why I say that maybe you can just make the Lua interpreter part of your project, right? So imagine like writing build scripts in Lua and then just like vendoring the Lua interpreter because it's rather simple, right? So, but maybe for simpler backend, it's still a little bit of an overkill, right? So I don't know, just voicing out my thoughts, right? Anyways, so let's actually continue like exploring this entire thing. And so how do you even use it? Do I just run it? Is there anything in README? Warning, unfinished and buggy. Okay, so we're gonna keep that in mind, right? So we're not gonna be too harsh in our criticism about the project, right? Because it's unfinished, right? So we have to keep that in mind. There's no instructions on how to build it, though. Well, I mean there is some instructions. So it's in the docs, and let's do building. So we already did the recursive thing. You'll need Clang. Really? Why do you need Ninja for? So does it? Oh, the Lua generates Ninja script. I thought it's like self-contained. It doesn't need additional. I'm disappointed. I mean, it's fine. It's just like it's kind of disappointing. Like I was hoping that it's just like literally self-contained. It just like only needs the C compiler, and it's just like. Anyways, that's already maybe better than CMake, honestly. Like generating Ninja scripts with Lua is better than generating them with CMake. Anyways, so what do we have in here? So Lua build driver. For the most part, doing Lua build driver will build a CLI app. If you wish to build the library by itself, add quick and TB depending on what is wanted. Alright, so I just expect that maybe there is a help somewhere here. So what if I just run this entire thing? It just builds. builds pretty fast. Is there something like help in here? There is no help, so we don't really. This thing is not particularly self-explorable. So it's a particular coding style build system you shouldn't understand. Well, I mean, it's pretty understandable so far, right? So it's just like it's a linear script. I don't see any particular coding styles so far, right? So it's pretty straightforward. It's pretty straightforward. I don't quite understand, like, so it builds just a thing. Then I want to build. So what did it say? Driver, right? So we want to do driver. Okay, so we're building driver. So the CLI app. Okay. And yeah, so essentially it's probably similar to QEB, right? Or LLVM compiler, right? That just accepts the textual representation of the intermediate representation and just translate it to different executables and stuff like that. So if I just do that, it builds. Yeah, it builds it like that. And if I want to do quick. Oh. And the quick is currently not compilable. Okay. So because it's unfinished apparently. All right. So that means we're gonna focus on the driver only, right? So we're gonna focus on the backend itself, just the backend itself. All right. Sodium backend. I'm sure it doesn't mean sodium backend, it's a tilde backend. Thank you so much, UC10, for 10 months of question with the message. Yo, 40 months, thanks for the stream. You're welcome. Really 40 months? Oh, holy shit. It is 40 months indeed. So Element0216, thank you so much for tier 1 with the message. 3 years goes by quickly. Been watching VODs more recently, but still enjoy what you do. Thank you, thank you. 36 months. Damn, so many OGs, so many OGs. VGLG, who took my name, thank you so much for trying with the message. Never been huge fan of LLVM. Have a great stream, my frunda. Thank you so much. All right, so it's kind of interesting. It builds quick. Right, but then if I provide quick, it can't build quick. But then I do driver, it builds successfully, but it builds a quick executable. I can't really understand this build system. What exactly does it build? Okay, so what if I do TB? This is fascinating. What does it do? Okay, it built TB. Right, so, okay, if I do all of them, it just builds probably all of them. There's an executable driver and a library. Well, I don't really see different executables, right? So there is only quick so far, right? So there's objects in here, here's the library, and here is quick. So let's go. Maybe the documentation is not updated, right? So maybe the documentation is not updated, but it's kind of weird. No input files. Okay, so let's create an empty file, right? So let's find out. It's not a file. Sorry. Let's actually touch it. Touch empty. So, and let's just provide an empty file. What is it going to say? It's trying to, okay, undefined reference to main. How do I create main? That's a very, so that means the empty file is essentially a valid thing, right? So it's a valid TB source code. But is there any examples? Do you have? There's no examples. Okay, that's very interesting. That is very interesting. So maybe there's something in docs. Okay, so there's IR. Sea of nodes. Sea of nodes is a SSA where ordering is relaxed in the form of explicit dependencies as opposite to local ordering. Okay, cool. Is there any examples though? So there's a README, code generation, nothing particularly interesting. Nothing particularly interesting. Okay. So freestanding tests. Okay, so maybe there are some tests in here. So here is the bar.txt. Let's open it up. So it's just a dump, apparently. Okay, so does it have to be... Oh, since it's a C compiler, it probably expects it to be... Yeah, it probably expects a C compiler, right? So a C program. So that means maybe it has to be something like C, right? And then I'll have to probably do something like that, right? Since it's a C compiler. So, okay. It's kind of ironic to write a C compiler and then link with Clang. But anyway, so the entire thing is not finished, right? The entire thing is not finished, so we are not judging that. So if I try to run it, so it should not return anything. Right, so maybe we can also include some stuff. So let's test the hello world. I wonder if the intermediate presentation actually has some sort of like a texture representation, like in case of LLVM or QBE. Right, so this is one of the things I remember there was in LLVM and QBE. But anyway, so we can do printf hello world, and if I try to build the entire thing, and then just maybe run, wait, so we didn't provide any output names, so yeah, it works. It's a C compiler. It can compile a simple hello world, which is kind of cool. But I'm really curious what's up with, like, I want to program with the intermediate presentation directly, right? So is it even possible? If I try to do something like bin quick help, there is no such thing as help. Okay, so there is some sort of a help. Okay, so that's pretty cool. Quick C compiler. So this is just a C compiler. So I suppose the intermediate representation is basically in the form of a library, right? Based. It has a based flag. It's experimental. It's just like use with caution. It is experimental flag. So it is an API. All right. So kind of interesting, honestly. So we can take a look at this thing. So here's a bunch of nodes. Optimize your crap. Okay. So some of the points I should probably worry about. Is that a texture representation or is that a pseudocode? I'm not even sure what it is. So there's the emit IR. Okay, so let's actually take a look at that. So you guys noticed something, right? So emit. Oh shit, that's actually cool. All right, let's fucking go. Emit IR. Ooh. Okay. So that's pretty cool. So it accepts memory. It's kind of similar to LLVM, honestly. It's kind of similar to LLVM. So what is this symbol? Right, and its symbol is not particularly accessible. What if I just redirect empty IR? Right, so I've got IR. You may want to employ this function. I really recommend to employ this function. It's a very useful function. Maybe I can disable the colors manually. Again, the project isn't finished. Okay? The project isn't finished. It's normal. It's okay. It is expected. So think. Aids in thinking about series. Okay. Waiting around. So people have told me that 2 minutes compiles aren't really that bad. So I figured that we should give them the freedom to waste their time. Wait. So essentially it's just waiting. As wait, is it really? Right, so in XK, it's literally waiting right now, right? So it's literally waiting, so it gives X. Oh yeah. Bro, it's spinning up my freaking CPU right now. Oh my god. Freaking... It is really spinning on one of my freaking cores. Fuck you. Okay, wait a sec. I wanna make sure... Holy shit. So where is it? Where is it? Where is it? How do I do that? Yeah, how do I grab specifically for... Okay, so let's actually grab maybe think. Do we have thing? Nah. So maybe it's somewhere in a driver. Okay, guys, so here is the thing. And this is the flag, right? So I suppose the way you search for this flag... Right, let's remove this kind of stuff. Right, toggle think. So let me see. Is it okay? So maybe it's arg think. How do you use it even? Arg think. All right. So parse code think. There should be some sort of a if somewhere. So here's the boolean. Yeah, boolean think. So we have some sort of driver args. So one of the things I want to do, okay, let's try to maybe put underscore in here. I want to find all of the places where this variable is kind of used. So let's try to build this entire stuff now. Right, so okay, so this is what I wanted. Yeah, so there you go. So I just was trying to find this specific place. Right. So, and what does it do? It's, okay. It's not even fucking waiting. It's not even fucking waiting. It's literally spinning. Okay, you deserve the star just for that. Just for the great sense of humor. Insta star. Deserves the star. Average experience, C macros. Yeah, exactly. Damn, that was funny. That was fun, my friend. I really appreciate that. I really appreciate a good joke. Spin for 2 minutes, right? So it's just like taking a piece at compilation times of LLVM and stuff like that. All right, so we got some Easter eggs. I already appreciate that. This is really cool. So quick, let's take a look at what else do we have in here. So we can think. Profile the compile times, okay, that's pretty cool. Enable multi-threaded compilation, change the target, set entry point, alright. So set Windows subsystems, Windows only, of course. Very sassy comments, just like a jive. So based, use the TB linker. Oh, it literally means based as slang. Right, so that means it uses its own built-in linker and stuff like that. Alright, that makes sense. It's pretty cool. Choose a language. GLSL? You can compile GLSL? That's very interesting. So run compiler persistently repeats compile step whenever the input changes. That's a very web dev-like. That's pretty cool. That is actually pretty cool. So if I try to maybe do live empty.c, right? If I do live, it didn't really do anything. So that's kind of weird. It didn't work. So emit IR. What I wanted with emit IR, actually, honestly, in all honesty, I thought maybe there is something to disable colors. Right, is there something to disable colors? I feel like there is no way to disable colors. Right, so we can try to do AST, well, I mean, AMT. Right, so here is the AST. Okay, so that's very interesting. That's very interesting. What's funny is that it feels really very much unfinished. It does in fact feel very much unfinished, but I like can't really find anything interesting to look at. But at the same time, people are integrating this entire thing in different projects, so that means there is something to it, right? There is something to it. So that means I need to maybe look further. For example, maybe we could try to use this library, right? So because apparently I don't think it has compilation, like it has a texture representation of its AR. So maybe what you're supposed to do, you're supposed to use it as a library, right? Maybe TB has more work in it than the C compiler. Yeah, probably. Probably we have to focus on TB rather than Quick. So yeah. Anyways, so let me see. But the question is, there's not that many examples on how to use TB. Well, we have a header. Okay, so all right, that's actually pretty cool. So there's a glossary. All right. So there's different things and stuff like that. A simple example would have been kind of cool. Okay, so here are different, I suppose, instructions of the intermediate representation. Yeah, node type, different nodes even, different nodes. But maybe. So there is also conf format linker x64. So maybe so there's some tests guy. Okay. So h.c. So this is just a hello world. I kind of want to try to maybe link with TB. Right, so it's actually 3 megabytes executable, so we can try to link with TB and try to use that. So let's create our own compiler, right? So let's create like my compiler, my C, right? So my.c. And in here, let's just do something like this. I'm gonna be using Clang compiler, right? So, but I'm gonna be linking with TB. Right, so let's create maybe makefile. So my.c, my.c, clang my.c, and let's just like literally link with TB. Right, so if you take a look at the bin, here is TB, and search for this entire thing in .bin. All right, so if I try to do make, it compiled and it linked with all of that, but we didn't use any of the functions from TB. So I suppose one of the things we have to do is do the includes. So we do have includes in here, tb.h. All right, so and let's include tb.h. So that also means we'll have to update this entire stuff and put include in here. Is it include? Yeah, it's just an include. Right, let's build it. Okay, so we build it successfully. Cool. So we have this type node thingy, right? Type enum node or whatever. So let's see where it is used. So you can get the name of this entire thing. Is that it? I don't really see the other places where it is used. So this is just a declaration of this type. Okay. But then you can also take a name, and that's about it. You can't really do anything. So, but there's a lot of these kind of instructions. So tb inst trace from region, save point, tail call, and so on and so forth. There's an optimizer API. So it would be interesting. It has a serious lack of examples. But I suppose maybe the compiler itself is the example. And maybe the compiler itself is the example. So SDG build primitives. So there's a docs, nothing particularly interesting. So there's a main. So this is a main driver. It's kind of all over the place. That's the thing. It's all over the place, and it doesn't feel like a coherent thing that you can just like properly explore. Right. Maybe there is a somewhere example folder like really nested in there, right? So we can just try to find the name example. Maybe it's examples or something like that. No, there is nothing in here. Okay. So there's also meta, not quite an LSP. Oh, it's a Lisp. There's a lot of things going on here. There's really like a lot of different things. Clean API. Well, yeah, it is. It's unfinished, right? So it's in this intermediate state, but at the same time, it's already being integrated in different projects and stuff like that. So TB code gen impl. All right, so C code gen for more details of the implementation. No, I would like to just have a simple example, right? So that's what I would like to have. It's intermediate representation. Okay. So maybe we should like look into the main driver, right? So let's actually start with that. So in here, quick parse args. So there's this joke. Cool. Starting with threads and stuff like that. Quick build step. Arg sources. So we are iterating the sources, right? And for each source, we're just doing quick driver CC. Is it defined somewhere here? It is not defined here. We can do something interesting. Let's find all of the files with the name ch, right? So here are all of the files, and let's just put them into e tags. Let's put them into e tags. Now I can try to do something like this. Okay, so we do cc, and so it creates a build step, right? So it allocates this build step and it just returns this build step, and it seems to be postponed, right? It's a postponed step. It just like fills up these things and returns this entire stuff, and we'll put that into this array of steps, which we then probably going to execute. So yeah, so here's we're running this step, and it's probably needed so we can actually run them in separate threads or something like that. Okay, so there's a mutexes in here. Yeah, so essentially each individual step can be run in a separate thread. Okay, that's fair enough. So, and in that step, what do we do? So it's actually rather recursive. Look at that. It is rather recursive. Oh, it's probably for the dependencies, right? So step, if it has dependencies, we're first building some other dependencies. Okay, so yeah, that makes sense. And when we're building the dependencies, what exactly do we do in here? So there's some tasks and stuff like that. So there's just a build step info. This is used by the worker routines. Okay, that's very interesting. So we add in a task. And this is a s invoke. And invoke is some sort of a function, so maybe that function is actually specified in here. So this is what is called in a separate thread. So it's a cc invoke. Okay, so driver preprocessor. So we're preprocessing the thing. Then we get the token. So here we finally parsing. So this is the token streams and stuff like that. That's pretty cool. All right, and where do we pass all of that stuff? So set extension, and okay, that's very interesting. So here's the tokens. So we got the tokens, get the files. Okay, is that it? Dump tokens. So this is a preprocessor. Okay, so this is probably a parser, right? This is probably a parser. Then we're doing compilation. Okay, so here's the compilation unit and translation unit and stuff like that. So add to compilation unit. So translation unit to compilation unit. All right, so what do we have in here? I didn't really do anything particularly interesting. So TU. Set to original. I'm trying to get to the point where it is emitting the intermediate representation, right? So then I can have an example on how to work with intermediate representation. So we're currently looking at how it is parsed. I hope so. And if we go down and down and down, maybe eventually we'll reach the TB itself. Right, so where it is emitting this intermediate representation, and maybe we can use that as an example. But so far, I don't see it. Right. So let me see. Dump translation unit. So maybe that's cannot dump translation unit. So it's quick dump. So translation unit. It's just statement. So it's a parsed thing. Okay. Allocate a. Okay, so we're allocating. All right. IR gen. So we take. Okay, so we're taking compilation unit, and we're finally generating different stuff in here. Okay, so that's pretty cool. All right. So quick TU CU. Number of statements. Okay, so you have IR gen task. IR gen task. This one is interesting. All right, that's a lot to take in, honestly. That's a lot to take in. So IR gen job. Okay, so maybe that's where we do that. TB. Okay, so this one is interesting. So TB symbol. Okay, finally we're actually using, we are in a code that is actually using something from the include tb.h. Right, we dig down long enough that we reached the intermediate representation thing. So this is a TB symbol, right? So this is a TB symbol, and I wonder what is a TB symbol? It could be actually, yeah, so it's part of this, I see. So this is type enumeration, but it's actually not that. It's this structure. Right, it is this structure. Refers generically to object within a module. TB function, TB global, TB external, and all subtypes of TB symbol. And those are safely allowed to cast into symbol for operations. Okay, so I really like that. So this is the symbol. So time block args. So then we take a bunch of statements and we perform this thing on the top level. Oh, and there's so there is a IR gen and there is a sequel IR gen 2. Nice, my favorite. So the IR gen was so good that they had to make a sequel. Okay. All right, so using the new TB builder because it's better. All right. That's very interesting. Thread local, is that a thing in UC? See thread local keyword. Wait, really? Today I learned. I didn't know that there is a thread local keyword in C. That's pretty cool. We're learning something. But man, this project is all over the place. This project is like literal definition of ADHD. Like, damn. So it's pretty cool, by the way. I really like this project, but it's all over the place. It's just like, what the fuck is going on? It's just like, it's a lot of like nodes, experiments, and stuff like that. It's just like, yo. All right, so, and I suppose, all right, this thing, so both of them implement irgen.h, right, if I understand correctly. So both of them implement that irgen.h. So I wonder, is it even mentioned in build.lua, right? So irgen. It's not even mentioned in here, so is it IR? No. Alright. Probably because, wait a second, because it's like automatically generated, so it probably traverses the folder, like it looks into the folder and just automatically adds all of the C files into the build, so you can't really find the you know, the coherent list of everything you build. But anyway, so we build in top level, right? So we build in top level statements of the language. Okay. So here is the function. You create TB function. So here you can also create some other things. So you also create sections, so you can create different sections for the module. Okay, so this one is interesting. So here's M, all right, and M, it's a TB module, all right, and module, how is it created? Okay, this one is really interesting because I feel like this is how we're supposed to do that. Right, we first create a module, but it's actually the module is created for us by the task. So the question is, how do you create a module to be... So yeah, it's already created. I kind of didn't notice that. But I suppose the root of everything is literally the module. So you have IR mod, which comes from the compilation unit, right? And this compilation unit is created by some other functions in here. So what I'm thinking is just like, how do I create the TB module? How do I create the TB module? And the next question is like, what then do I do with the TB module? All right. So tb.h tb module. So I think I saw it, right? So it's TB symbol, but what I'm interested in is TB module. So struct TB, yeah, this one. But I don't see. Are you telling me this? It is opaque? Are you telling me it is opaque? It looks like it's opaque, huh? So so this is just an include, and here is a TB, and if I just look for TB module, right? Maybe it's defined somewhere here. You know what? I think I need to make a small break and make a cup of tea. Right, so after I make a small break and make a cup of tea, we're gonna continue exploring, and here is an internal. So it is apparently supposed to be, yeah, opaque. It is supposed to be opaque. Huh, very interesting. But maybe there is a way to allocate this entire stuff. So do you have something like a function that returns that stuff? Like there's no way to create TB module. TB module create, TB module create. Wait, why couldn't I find that? Am I an idiot? I think I just like mistyped something. Okay, so you can just create. Okay, so this is kind of cool. So, and I wonder, by the way, is there any functions that accept TB module and allow us to do different things? So I really like this function, by the way. So module enable. Sorry. So this is actually kind of cool. So we create module and we create sections, and yeah, so we just like pile different things into this TB module. The next question, how can we now transform that module into something, into object file or whatever? So let me actually find like all of the places where module is used. TB module create, you will create for host. You can destroy that thing afterwards. Enable check stuck. You can do git begin. All right. Object X. Is that it really? So then you get the expert buffer. So do I understand correctly that I just create TB module, just add a bunch of things into that module, for example, function and whatnot, and I just export object out of that, and I get like some sort of object out of this thing. So I can even, and then I can export that buffer into a file. Look at that. I can then export that shit into a file. Sounds pretty simple, right? Even though there was no example to do that, but we can try to do exactly that. Let's actually try to do that, right? So I'm gonna try to do a very like naive first thing, and then if it doesn't work, we're gonna go onto the break and make a cup of tea, right? So let's create an empty module, right? Let's see what's gonna happen. Let's create an empty module. So here's the my compiler. It's pretty cool, right? So that we managed to kind of like wrap our head around this API by just looking around in the compiler. So that's already better than Lagrange, right? So tb create, what was the tb module create, right? So here we go. Okay, that's cool. Let's fucking go. So here's the module, and we managed to create a module. I'm gonna call it M. So what kind of architectures do we have? So I suppose we are at x86-64. So that also means that I can cross-compile this entire stuff. Right, so that also means I can cross-compile. Okay, fair enough. So TB system. So what is the TB system? What kind of... Ooh, is it not defined in... Why is it not defined in here? Bro, what the fuck? Where do I get that? So there's a prelude. Okay. Yeah, there we go. Okay, so we're going to be compiling... You can compile to WASM. Android not supported yet. I wonder if you can compile to WASM32. Right. There is for host. Oh, that's actually very interesting. All right, so let's actually use system Linux, right? So that's the system. And let's not use JIT for now, right? So I didn't really think we need to do that. So it's going to be false. So, okay, afterwards, I'm going to just print m equal p. And I just want to take a look at it. I just want to see what's going to happen. So we're going to make, and let's just run the whole thing. All right, so we got some sort of a pointer. Wet assembly. Yeah, very funny. And you know what? Let's just take this empty module and try to translate it into an object. Why not? Let's try the simplest possible thing before jumping into something more complex, right? So I think it's fair. So TB module, right? So TB module, so we created that. And yeah, so here we need these two functions. I'm gonna comment out this one for now. So here we get the buffer. And honestly, I'm not sure what the hell is buffer. Oh, okay, so it's just a structure. So I suppose it's a linked list of chunks. Yeah, it is a linked list of chunks, believe it or not. Right, it's literally a linked list of chunks. Okay, fair enough. So here's the module that we want to provide, and it accepts Arena. Look at that. So Arena, it is using Arena. All right, so how do we create Arena? So I suppose you have to explicitly create it, apparently, right? It's not like my Arena where zero initialized Arena structure is actually valid. You have to create it, apparently. So for those who doesn't know, I have my implementation, like very simple implementation of Arena. So it's probably simpler than whatever is used in this compiler, but I like this implementation because you can just like allocate it on the stack, right? In the sense that you can say Arena A 0, and this is a valid Arena. You don't have to have any initialization function or anything like that. You can start allocating into that structure, and it will initialize everything like automatically for you. You don't have to worry about that. I kind of like this kind of API where you don't have to call any special functions or anything like that. You know what I mean? But I mean, it's not that big of a deal, right? So I'm gonna just assume that the way you work with this Arena is you just allocate it somewhere, for instance, on a stack, right? So we just do TB Arena, and we're gonna call it A, right? So I'm gonna just like zero initialize this entire thing. And afterwards I have to create it, right? So I have to create it somehow. So there's also optional tag. So I hope I can just put null in here. And in here, I'm going to just say, okay, create and initialize this specific Arena that I allocated on the stack. So I hope this is how it's going to work. So, and all of the allocations for this by this function are going to be done into that specific arena. So this is going to be A, and some sort of a debug format. So let's say that we're not going to have any debug format. Okay. So we get some subs. Siphon, thank you so much for the sub with the message. Merry Christmas. Which one? Which one is that? So we'll get some more subs. Thank you so much, Black Haze, for Twitch transcription with the message. Long time without wasting my subprime with yet another recreation program session with Mr. Azuzin. Thank you so much. And Heot, H3UT, thank you so much for tier 1. Thank you. All right. Chinese Christmas. I didn't know that Chinese are Christians, honestly. Is there a Christian Chinese? So as far as I know, yeah, so there's many religions in China, so maybe there are some Christians in there. All right. Not that many religious people, right? Not that many religious people, but there's many religions. Underground, I see. Anyways, so debugger from T none. Now, I suppose, I don't even know, so it will just export this entire thing. And let's go ahead and try to call this entire function. So I'm gonna just put buffer in here. So it's gonna be, it's called buffer. So this is buffer. And the path is going to be, so output, right? Let's call it our first output.o. Okay. And I suppose if it returns false, because otherwise why would you be out? Be out, let's call it be out. Bout. So I suppose if it returns false, that means it failed, right? Let's do something like could not export export file s. So let's call it output path. Const char output path, like so. And yeah, so maybe there is a way to actually get the proper error message, but I don't know how to do that, so I don't care. And in here we're gonna just return 1. Okay, so I hope that's the basic usage of this API. I think maybe that's what it is. All right, so let me try to just build this entire thing. So destination arena has to be a pointer. I see. Okay, that was easy. That was easy to compile. Let's try to run my. Okay, so it didn't. Energy generated B out. So if you take a look at the type of this file, it's an ELF64-bit LSB relocatable executable, not strict. That's pretty cool, right? So, like, it doesn't have any examples. It doesn't have any examples. We figured out how to use it. Not bad. Not bad. Simple enough API that you can just look at it and kind of understand like how to use that. Unlike Lagrange. So, all right. So I wonder if we can like link this entire stuff somehow. If I try to do just like LD out B and just B out, it's probably going to fail. It doesn't have any start. So I suppose the next logical step would be to create a function with the name start, right? No particular coding style. Yeah, exactly. So the project is unfinished. Like look at the bigger picture. Look at the bigger picture. The project is unfinished. There's very little documentation. It is all over the place. There's no examples. We couldn't find any examples. We just look at the header. We just look at the code of the compiler, which is hardly an example because it's rather complex application. You can't really use complex application as an example, right? So we look at the API and look at the how it is in the compiler and figure that out. This is good. This is good. Obj dump. So we can do obj dump. So obj dump specifically here. Well, I mean it's empty. It's empty file. Anyways. So what do I want to do? There should be something like TB function. right? There we go. TB function. How do we create a TB function? JIT wasm object. Is there any way to just like create? Okay. So symbol as a function. Symbol as function. Read elf a b out. I don't think read elf is going to tell us anything particularly interesting. Well, we get some sections though, right? By the way, how does it generate all of that? We need to reserve. So it's not using any assemblers or anything like that. It literally generates like, really? Wait, I didn't think about that. So it doesn't use any assemblers. Which I mean, it's backend by itself, right? Row dog in x86. Not only row dog in x86-64, row dog in elf. I think this row dog in... It is fucking row dog in elf. That is based. Holy shit. Row dog in elves. Impressive. Fucking impressive. Not bad. Not bad, not bad. Dash based. Yeah, dash based. Dash based. I really love it. This project is something. I'm telling you. This is I love it. I absolutely love it. It's definitely unfinished, right? So it's kind of, I don't know if you can use it in production, but I mean, Odin is trying to use it in production, right? So some other projects also use it in production. This project makes you think. Yeah, exactly. It makes you think. So what I want to do, I want to actually kind of generate like a hello world. Like, is it possible to generate some sort of a hello world, like purely from the C program? That's a really good question. That's a really good question. Let me see. So we need to create a function. And I wonder if we can just figure it out how to do that. So there is a, you can create a function from a symbol, right? So that's one thing. So save point get, I don't know what the fuck it is. So wasm, we don't need wasm. Place function, this is JIT. All of that is JIT. So setting prototypes or something, attribute scope, doesn't matter. So this one is interesting. So this one function is interesting. So I'm gonna save it. So inst location, probably not that interesting. Okay, so you can create function in a module. Okay. So that's cool. Which is probably exactly what we need. So we just create a function within. We can already just go ahead and try to do that. Just try to create a function within the module. Maybe even an empty one. Okay, so this one is going to be f. TB module, we just put m in here. I have no idea what the fuck is length. What the fuck is length? Length of what? All right. So the name is going to be start, obviously. Pointer div. Pointer div. Is that a... I don't know. It's kind of difficult to tell. But we can always grab the whole source code and just like find it out. Okay, so this is linkage. This is public. Okay. So far, I can kind of understand how to use this function, except the len. What the fuck is len? It's not even self-documenting really well. All right. Oh, by the way, it still created B. So, so LDD, not a dynamic executable. So, Right. So let's remove that. Yeah, we need to do grep. Let's try to grab this function. Grep rn. What do we have? Okay. Cool. Len. Atomic len of the name. Ah, it's a. Seriously? What is atomic though? Okay. It's just a length of the name. Why length is not after the name? Usual convention is that the length of the string is up. So it's not. All right. I see. It makes sense, right? So usually when you write in a compiler, you have the source code, right? So you're probably not going to have null-terminated strings, right? So because you're taking the strings from, you know, from the file and stuff like that. What was that function? Character minus, yeah, that's actually in freaking Pascal strings, bro. Oh, in by atom he means like atoms like in Erlang. I thought it's like atomic values because it's a multi-threaded or something like that. No. It's atom like symbols, like Lisp symbols or Erlang atoms. It's name. That's what it is. Right. Okay. And they have length as a prefix. All right. Okay, fair enough, fair enough. But anyway, in our case, we probably don't even need that, right? We don't really care. So what I want to do in here is just like a start name. So this is a start name, const start name. I'm gonna put it in here, and in here we're gonna just do strlen start name, like so. And I wonder if we need to do anything in here. So I suppose as soon as you create a function, it's created within that module, so it's going to be added to that module. So the only reason why we have this handle is that maybe we want to add more stuff into the function. So why is that ptr diff though? Maybe because you usually have const char begin of the function. You know where the string begins and you know where it ends, right? Because you have a file, you loaded file into the memory, and then you found a substring. And since it's a substring, it's not null-terminated, but you kind of know its begin and its end, right? To quickly get the length of the begin and end, you just subtract end, like begin from end, and usually the type of this difference is ptr diff. Right, if you have 2 pointers and you subtract 1 pointer from another one, you get ptr diff. So to kind of reflect that this is kind of what expected in here, maybe that's why he put ptr diff in here. But this is just like I'm confabulating that out of my ass like ChatGPT. I not back that by anything, right? So again, pulling that out of my ass. But this is just like a minor detail. I don't usually pay too much attention to this kind of thing. Anyways. All right, so let me try to maybe build the whole thing. Zozin GPT, exactly. Okay, seems to be building. So now if I try to run this entire thing, didn't crash, which is nice, right? So, and we can take a look at the names of b out. Yeah, didn't print anything. Look at that. Didn't really print anything, even though I asked it to create the function. So let's do the following thing. So as soon as you create a new module, we're going to say module is equal to p, which is m, right? So, and this has to be n. And in here, we're going to just say f. So let's rebuild everything and let's just run it. Okay, so both of these things were successfully created. And if I do nm, still no symbols or anything like that. And now if I try to do ldo b out, it still can't find the start. So that didn't work, right? It didn't actually add this function to the module. So we'll get some subs. Thank you so much, Alex over 6 for the subscription. With the message basis programming indeed. Voxel Rifts, thank you so much for tier 1. Thank you. Yeah, that's kind of interesting. Maybe we have to do something else, right? So maybe creating it for the module doesn't really add it to the module. Right, so it kind of associates it with the module, but it's like not that. So TB function, right, maybe. So let's actually take a look at what other functions we have. So we stopped at somewhere TB function create. Okay, TB function. What other functions do we have? So instruction poison. So get prototype, set prototype, but I'm not sure if I want to set any prototype. Ooh, I suppose this kind of like adds in. This is cool. Look at that. This adds instruction to the. You can kind of program like an assembly with this shit, can't you? Look at that. So you can just kind of like have an assembly within the C code and just like add instructions and shit. I would really like that. Really like that. Okay, so so this is array access, member access, get symbol instead, and here are all of the instructions. If this is the actual interface, this is based. Honestly, this is based, but I want to get past that. I want to kind of get past that. So instruction region, all style uses region for all control flow. Okay, new trace. OPT dump stats, JVN, TB print. Ooh. So print SSH you will look in form. Print SVG. Print dump. Alright, so I want to try to do this thing. So I'm gonna put this stuff in here. Alright, and it's segfaulted apparently. Fascinating. So TB print like literally segfaulted. I wonder why though. So if TMP is null, it will use the function's TMP arena. So function may have an internal arena somewhere. I don't remember setting that arena anywhere, but so it's a closed function. Yeah. All right. To function code gen. So output goes on top of the code arena. So maybe this is what we have to do. All right. So what I'm thinking is that we need to take a look at like more examples within the code base. Right. So let's just try to grab this entire thing one more time. So this is our gen. Right. So let's just see where this function is used. So backing F. Okay. All right. So we saved it in here and then we just do that. And how do we use this func? Okay, so you can set arenas for this thing. All right. So this is probably the arenas it was talking about. It's not really obvious from the interface of this function is that's what you have to do. And it's not even available in here, but maybe it's available in Prelude. It's not even available in Prelude. So do I have to grab it in here? It's not even available in here. That is bizarre. So where is this function? It's not available anywhere. It doesn't exist. This function does not exist. So we set arenas somehow, but we don't really know how we set it. How do we set this arena? Does this code even compile? So I feel like this is not compilable code, right? So because it's... Yeah. So maybe it's in IRGen 2, right? So it's probably... The IRGen itself is not even used, right? So create function. TB function. So here we create the function prototype, but where is the... Okay, so there is a target in here. Okay. So... Mm-hmm. Oh, and this is how we create instructions. Look at that. Get memory order value. But I mean, maybe this is not instructions. So there's a lot of function prototypes. So here's the prototype, but there's no function themselves. I'm just thinking, how do you add that to the module? That's the thing. How do you even add that to the module? Yeah, I don't see that. I don't see how you add it to the module. Because, like, I would expect it to be at least an empty function. All right, let's make some break. And I'm going to make a cup of tea. And after the break, we're going to try to figure out how to at least add an empty function to the object. Right? Sounds good? Sounds good, shit? Let's fucking go. All right, so let's continue. So in the chat, somebody suggested to look at this interesting place where we look at the declaration of the main function. I wonder if there's something like a start. So, okay, so there's a VA start. Yeah. So, and what's funny is that we don't create a function in here. Function is not being created in this gen. So there's only one place where the function is created, like explicitly with tb function create, and that place is not even compiled at all. So here's our gen, so here's that function, and yeah, so our gen, like a first one, is not even compiled at all. We already kind of know that, because it calls to some functions that don't exist, essentially. But maybe that is fine. So there's a global, tb global create. Wait a second. What's that name? Maybe that's what we have to do. So tb.h global. Okay. Ooh. So it's a name debug type, and debug type is what? It's a struct. Maybe that's what I have to do. Creating function might not be enough. You have to kind of mark it as global. So that could be the thing. Okay, let's give it a try. So, and also tb print is not going to work. You need to set its arena, so let's not do that. So here's the global. We're gonna call it G. So we're creating it inside of the module, and this is basically the name. We can kind of do a similar thing. So size t is going to be start name len, strlen start name. Right, so this is going to be start name len, start name. I'm not sure about this debug type. So what the hell is debug type? So I was thinking that maybe it is enough to just mark this thing as linkage public to make it, like, you know, public, but apparently it is not. I think you also need to create a global thing. So, but the debug type is kind of a weird concept. So, and it's opaque. It is completely opaque. And if we take a look at the usage of this function, so create global. Oh, sometimes you can actually put a null in there. Yeah, so I suppose it's related to the debug information, and we explicitly don't generate it in debug information, so maybe it's fine. So let's put G in here. Right, so we put in G in here. So we create a function, and then we create a global with the same name. Hopefully that actually makes the function public. We'll see. I don't know. One of the things we can try to do is maybe add all of that stuff to here. So b out is my, and we just called my like this, right? So then I can say quite easily, make b out. All right, and it aborted. Nice. Where did it abort though? Huh. Okay, so let's actually put some sort of output in here. Generated as, and this is going to be output path. Generated as. Yeah, so it aborted somewhere, but I don't really know where. So foo and here's bar. Yeah, so when we try to generate, it didn't even tell us where exactly it aborted. Yeah, it didn't even tell us. So tb create just aborted for whatever reason without any explanation. So because it literally called abort. If we take a look at here, so here is the stuff. It's probably has something to do with memory allocation, really, because here we can't really like abort anything. So where did it abort? Okay, I swear to God this is because of the arena. So it tried to use the symbol alloc. And within the module, right, so within the module, what does it do? So it's in4, so it takes the tb thread in4, and it takes the perm arena there, and it's probably, well, yeah, so there's some sort of assertion in here, but I would expect assertion to at least tell me where it happened. In our case, it just aborted. So this one is rather interesting. Maybe we do have to create this section. Maybe we have to create this the kind of section. So, but maybe so the library itself was built in a weird way. We can take a look at the Ninja. It's not particularly readable, I'd say. It doesn't really do anything special, honestly. Right? It's just like it builds things without any additional flags or whatever. But, yeah. It's kind of bizarre. RGGen. We can just go ahead and try to create this section. Com.dat. Alright, so section handle. tb module get text. So if it's inlineable, well maybe it doesn't matter. So you don't have to do it like that. Yeah, so the .text was already in the output. I agree with that. It was already in the output. So my hypothesis here is that we have to associate the arena that we created in here with the module. I think that's what needs to happen. So tb arena create. So you can create arena. tb module export. So when you export in, you can provide arena, but I feel like modules have their own arena. tb function get arena, so you can also associate function with arena. So tb code gen out goes and code arena. Yeah, I don't fucking know. It's really bizarre. So gen2. Ha, very funny. gen2. Haha. Function type, function name. So if I take a look at the function name, it's not even fucking used anywhere. Alright. So then you create a name length. So then you create a global. I wonder if that's because there is already a function. What if I just create a global? It's floating point exception. Okay. But so it managed to create, and then it doesn't even explain. Right, so if I create a function, it's aborted. If I don't create a function with the same name, it's a floating point exception. Debugger time, maybe debugger time, but I feel like it's not gonna be that helpful. But let's try to do that anyway. gf2 main my right. Oh, gf2 my. All right, so let's just run it and align up. Okay, so that was at least helpful. So thank you for suggesting that. So module object export, it tried to export object to write output. So layout section, line up, and so it only may happen if b is 0. So that means align is 0. So that's the problem in here. GF not found. Yeah, exactly. GF not found. So when we create a global, by the way, I just exited incorrectly. Yeah, so everything's fine. How do we create alignment? Do we even create alignment in any way? I don't know. But by the way, so maybe we can now try to do the following thing. I'm gonna try to do gf2 my like this. Let's run it and see where exactly symbol alloc, right? Global create, then it did symbol alloc, and then it's just like somewhere in threads, kill implementation. It didn't really tell us where exactly it aborted. It just like aborted somewhere here. It tried to allocate the symbol, but something happened. So maybe there's like symbol collision. How big is the arena? I have no idea, but it's supposed to grow automatically. That's arena, isn't it? So we created the arena and stuff like that. Okay, so tbh, create optional tag. Okay, so what if I just create a boba? So this is a boba tag. Didn't help. That didn't help at all. So but if I just do something like this, right? And I just generate that, it generated b out, but it doesn't contain anything. And we can also take a look at red elf a. It has all of the sections, stacks, but maybe like you have to specify in which section you create all of these things. Otherwise, it just like doesn't make any sense. Well, it must be simple, right? I swear to God, it must be simple. Otherwise, what's the point? To be a function. So there's also function output. There's where machine code and other relevant pieces go. Okay. Why are you selecting everything? Emacs, stop. To be function. Save point. JIT place function. Symbol as a function. Set prototype. As simple as LLVM killer could be. It's not finished though, right? So it's kind of difficult to like assess this project because it's only a start point, right? So maybe in the future it's going to be much better. Is this because there's already symbol with a stat? There is no symbol with a stat. There is no such symbol. That's the problem that we're trying to solve. Look, there is no symbol with a stat. That's what we're trying to solve. Like, where is the symbol? There's no such symbol. But maybe symbol, speaking of symbols, maybe we need to create a symbol for this entire stuff, right? So let's go ahead and create a symbol. So because I remember there was a way to create symbol. So to be symbol. Right. Extern create. Oh. Let's go ahead and do that. Maybe that's what we have to do. So let me see, maybe there's some examples in here on how to do that, maybe within the source code. Okay, so here's okay, so there's some stuff in code gen, right? So backing s, and there's a declaration. Yeah, let's just go ahead and try to call this function. external type. This is fascinating. Main.c, main.c. So instead of global though, right, let's not create a global, but create a symbol. So this is the thing. So start name length, start name, and then we grab the whole thing in here. So and export outside of the shared object. Yeah, so that's probably what we want to do in here. All right, so this one is going to be S. Be out. Okay. Still nothing honestly, right? So it didn't create anything. So there is also a very interesting function which accepts a symbol and creates a function out of that symbol. Let me see. So here's the create. Oh, so places relocation. Ooh, this one is interesting. Places a relocation for a global at offset. I suppose global is a, yeah, I don't know. So to be symbol as function. To be symbol as function. So places relocation for global, maybe that's what we need in here. Again, a simple example would have been great, but I mean, the project also not finished, so you can't really demand that. So kind point, so here's the module, G, we don't really know what is G though. So yeah, gen global initialize. So maybe function add. Maybe there's something like function add. Nah. Function creates a symbol. We already look at that. Create from symbol. So it's not. It doesn't create it from symbol though. It doesn't create it from symbol. It says as symbol. It doesn't imply that it's going to be created. That's the thing. So symbol as function. It views symbol as function. So it's kind of like, it's a very vague thing. It's a symbol as function. We can take a look at maybe implementation of this entire stuff, right? So what exactly does it do? Symbol as a function, and it, yeah, so it's just like, symbols can be different things. So that means that symbol has to be marked as function. What our symbol is actually marked as? Is it even marked as anything? You know what? I think I need to debug my thing. So gf2 main my, right? So let's just go there. I'm gonna break at main. I'm gonna just run. I don't have a debug information. I don't have any debug information. So let's actually create some debug information. So this one is going to be GDB. I'm going to do make -b. All right. So, and then I'm going to just do that. So break main, run. Okay, so we can create a bunch of things. And I've got S in here, right? So here's S. Okay, so what's funny is that it is a function. How does it know that it is a function? I don't remember explicitly saying. Is that because I used the same name for as the function that I created? That is fascinating. That is actually fascinating. So that means, what if I remove the creation of the function in here? What if I remove it? So break main, run. We can try to create symbol. Okay, so we created a symbol, and then if you take a look at that thing, it's just an external. So that means this symbol is related to this function. Aha! We're kind of on the right path in here. We're kind of on the right path. But we still can't see anything. Right, if I just try to create this entire thing, so B out has been created. Let me remove it just in case. Just in case. Right, so generated B out one more time. Still no external stuff. And then B out. Right. So something. Maybe you have to be expert in some way. Maybe edit or something. Let's take a look at what kind of stuff you can do with symbols. Symbol. So this is a wrong file. TB symbol. Extern create. So, and this is what we were using in Maya, right? Yeah, this is what we were using. Global add symbol realloc. Symbol as function. Set name. Bind pointer. Symbol address. So there's this builder thing. So it's a graph builder, I suppose. Builder symbol. Are we sure this symbol doesn't get skipped because it has no code? I'm not sure about that, but we can't be sure about anything because there's no good example, right? That would have just demonstrated. Okay, so here's how we create an empty program. That would have been perfect, honestly. Just like a starting point. That's how we create empty thing. But I mean, we have nothing. And the project is unfinished, so we can't really blame the project for that. Okay, so we created an external. Do we do anything else? And builder symbol. And we also kind of return that out of the function, and we have a value description of some sort in here. So, and G in our case is what? TB graph builder, right? That's what it is. It's a graph builder. So I don't really know how to use that graph builder, honestly. Maybe there was some sort of documentation in there, but so builder enter, and you provide a function. This one is interesting. This one is interesting. I think that could be it. Yeah. So, is there any examples? Okay, let's actually from DBG, right? Baba G. So you provide the F. What was the F? F is not defined here. So it means F is defined. Let me see F. So where's defined F? There's no parameter F anywhere in here. Just F. So yeah, so you enter a function and you just exit immediately. Is that what you have to do? Maybe that's what you have to do. I don't mind. I don't mind at all. My C. So we provide F and we just do that. So it's not a want. I want to just build. Okay, so arena. How to provide the arena? Arena is this. We do have arena. So we didn't like something. Too few arguments. Are you serious, my friend? Oh. So, yeah, this is completely outdated code and it's never even built anymore. I should actually stop looking at our... Yeah, there is a whole file in here that is never built and contains completely outdated code that has nothing to do with reality. So yeah, it's like I don't know what to. It's definitely unfinished. It's definitely unfinished code. All right. So zombie code, exactly. Builder. So you provide a section, debug type, and null. I think it's kind of similar to that. So a section, in terms of section, what kind of section do we use in here? Yeah, so it's probably something that we have to do in here as well. Right, so here's the section. So do we use the section anywhere else? So we create the function. And the func itself, when we create the func. So it's unclear what the fuck is this function. Backing f. We don't really know what it is, but it's just some sort of a function. Right, so we create that. But does it really have to be dbg? I don't think it has to be dbg. So we just create a bunch of things in here. And I just do that. And I think dbg has to be null in our case. Yeah. So function proto. This one is interesting actually because it doesn't accept proto. Yeah, maybe we have to use dbg in this case. So this is null and a work list. Yeah, this kind of interesting. This one accepts some sort of a function prototype. Parameter address available through parameters. They are not tracked as mutable variables. Okay. So and after that, so maybe we have to build a symbol within this thing or something else. But yeah, so just now we are doing exit. Okay. So here it's just f and it's segfaulted. Okay. All right, let's try to run this entire thing. It's segfaulted at function returners. Oh, this is because it does want to have dbg. It does want to have dbg. Babaji. Right, so let's not do dbg then. But if we don't do dbg, we have to provide the function prototype, and I'm not sure what kind of function prototype we can provide and what is it even, but maybe I can put the null in there. I can't. All right, so if I try to just see where exactly it failed, yeah, so that's kind of funny. So from it still uses, yeah, it still uses this kind of stuff. So that means maybe we can take dbg type. Man, I don't know, like some prototypes, call prototype. Is that it? Can we just create something else? Okay. So you have target. Can I just, I think I can use something like this. So after creating a function, I can just try to get its prototype. So can I just do something like f? And just put it in here. Is that something I can do? Yeah, just use the prototype. Are you gonna be happy? No, it's still segfaults, but now if I try to run that, yeah, so it just doesn't like something about the function. Oh boy. Mainly the second / main comment is interesting. I have no idea what you're talking about. I'm moving too fast. I'm moving too fast to understand. So in case you want to check working example, here's the check this issue. Okay. All right, let's take a look at this issue. Oh, okay, finally. Jesus fucking Christ. It should be somewhere like in a visible place. Yeah, this is what I wanted. Just give me an example like that. All right. Thank you. Freaking finally. So thank you so much. So these kind of examples are really important, really important, so you can just like you know, grasp them. So here we created a module. We already created a module, and then we got the section. So in our case, did we get the section? We kind of figured out that we have to get the section, so we managed to figure out these things. which is cool. So prototype param, printf return. I don't want printf return or anything like that. So we created a function, and the main, we have to create the prototype. Okay, so that's understandable. So, and the main return is, what is the main return? So it's a prototype param, main return. And then you set the prototype for the... Okay, so on top of just creating a function, you also have to create its prototype and set that prototype. Okay, fair enough. So then instruction call, I'm not really sure if I care about any of that stuff. I'm really curious, like, how do I add this function now? So it appears to be adding some stuff into this function, but I don't care about that. So module object export. Well, yeah, so we know how to do that. So then we're exporting that to file. Is that actually it? Is that actually, do we need to do anything in here? To be pass, enter. Oh, it's passes. So what the fuck is a pass? To be pass. To be pass. It's not even there. Passes. To be passes. It's not even there. Okay. Maybe I just like referring to that incorrectly. Come on. Am I doing that from a wrong place? Who said it's a working example? Excuse me, but how is that a working example? It's referring to things that don't exist. How did you come up with the idea that it's a working example? I don't understand. So, another dead code. It appears to be another dead code. It appears to be another dead code. We can literally just copy paste this entire thing. So what I like to do is to just like dissect the examples, right? They said working. Somebody in the chat said working, right? So, but it doesn't appear to be working because it's using type that don't exist. Right, so let's do working.c. Okay, so let's actually see. Working in quote. Okay, I'm sorry. I'm like, listen, I have to focus on too many things. Cut me some slack. So working. So make file working working.c, and let's actually stupid. All right, so okay, working. All right, minus b, and yeah, obviously we can just do something like this. Sure. Yep. Too many arguments. It's stale code. It's not relevant anymore. It's not relevant anymore. Maybe I'm actually kind of... maybe there's some releases in here. There's the latest release. Surely to be passes generated by macro. Yeah. But anyway, one of the things we can do, we can steal some information about like prototypes and shit, right? It's one of the things we can do. We can create a prototype. tb.h, create a prototype. So yeah, calling convention. So maybe it is somewhat useful. Maybe it is. And it has to be done after we created a function. So here's the function. All right. So, and in working, so here is the, it's called start f, right? So this is a start f. Let's not do anything, but maybe we can do start f in here. Start f. So then this is going to be start prototype. We provide the module. Call convention is going to be tb std call. The amount of parameters is obviously 0. Since we don't have any parameters, it's going to be null. Return parameters, let's actually say that it's also going to be 0. And this is, I suppose, prototype parameters can be also 0, has var args, false. This one is easier actually. It's easier than main because we don't have to return anything. This is pretty poggers. Okay, so then we can do function set prototype, right? So we can do function set prototype. Yeah, but not from dbg, right? So it's just this one. Function set prototype. So this is start f section. We do already have section, right? So we grabbed the section. Let's call it text section. Text section, and the prototype is the start prototype. Right. So, and then in working, after we start the prototype, so we populate this entire thing, doesn't really matter. So then we do pass enter or whatnot. Maybe we don't have to do that, honestly. Okay, so let me get rid of the graph builders and symbol builders. Symbols are for the symbol-minded. So let's now try to compile all of that stuff and see what's going to happen. Though I would like to maybe remove this thing. Right, so it generated something. Okay, cool. And still does not contain shit. Cool. Now let's bring back the symbols for the symbol-minded, right? External, so expert. It's so fucking expert. It's insane. It's fucking insane, mate. All right, so we've got some symbols, and now still can't get shit. Still can't get shit. So maybe there's some functions. No, tb pass. Yeah, so there's no tb pass enter. So tb build enter. Though we have a function prototype. We can try to do some, yeah, so we can try to do some shit with that. I don't know why I decided not to. Yeah, so there we go. So we have a prototype. So this is start f text section start prototype. And then it also accepts work list. We don't fucking know what the fuck it is. So if it's not equals 0, I'll run the peepholes while you're why? Because it avoids making junk nodes before. Okay, thank you, very useful information. So then we're just doing that. Is it going to help us with anything? At least it didn't crash. At least it didn't crash. I appreciate that. No, didn't create anything. Okay. So this is a text section. Okay, working, so-called working example. Did we miss anything? Did we miss anything? So we have parameter nodes and stuff like that. Was it just illuminated somehow? But I mean, I marked it as external, so that's the thing. I marked it as external. So this is just a parameter prototype and stuff like that. Export buffer. Maybe builder enter is a new version of pass enter. Yeah, I also think so. I also think so. So we also maybe have to create a global. What if I make it global? Oh yeah, so there's a little bit of that. Yeah, so you can't create a global. And also, and honestly, the working example, you know, doesn't have any globals. Maybe so external means that the linker needs to provide the function. Maybe. I don't really know. But do we do the thing? Yeah, it's a printf, but for the main... So let's not do that. So we never have to actually... Yeah, we never have to make main external. We only made it linkage public. So that's what's interesting. No. I don't know. I'm really confused on what the fuck is going on. So I can't make it working. So I just want to have a function, like an empty function, doesn't have anything. Even smaller working example. Okay, so let's take a look at that. Let's take a look at that. All right, function linkage private. Linkage private. So instruction return. Okay, we can try to do something like that. Just add one instruction. Maybe that's the problem in here. You know? What's that problem here? Let's try to add one single instruction. So count and yeah. So after we created a function, so it's gonna be start f. We don't have any parameters in here, and this is gonna be null. All right, so empty. Everything's empty. Everything is freaking empty. So, and it also uses passes. That is not a thing anymore. Is missing TB prototype function. TB passcode gen. TB code gen. Right, output goes into the top of the arena. If that's what we have to do we have to do TB code gen? So work list, arena code, arena feature set. I don't know. I honestly don't know. I'm really confused. TB code gen. So we can try to call this function, but where do I call it? Where do I call it? So because it's missing TB prototype, we can use TB set proper to do that. Also, emit as a flag on passcode gen does not print assembly, it just emits it into the buffer. You can then do all right. To put it in a standard output, you can, okay. But where do I do that? Where do I do that? So to print to this std output. Oh my god. So do I do that between building the graph or not between building the graph? I'm actually thoroughly confused. Start output. So this is a start f. So we have also some sort of a work list as a last thing. As a last thing of what? Okay, whatever. So a. So feature set, now we have feature sets, and I don't really know what the fuck is a feature set. So there was some feature. Okay, so we can maybe get this thing. So this is features. All right, emit assembly true. Without the graph, before the graph, after the graph. What is? I don't fucking know, bro. Okay. So, and it's sec false. If I don't do this kind of shit, it doesn't sec fault. What if I do that before this thing? It's sec false. It always fucking sec faults. Pass code gen at the end. Okay. Fucking hell. So what's interesting is that is that where we do that? Circfolds. Where does it circfold down? So let's close this one, run, and WS. It doesn't like that I gave work list as empty, but they're using a version of API that didn't have all of this work lists and stuff like that. That's the thing. So they're using a simplified version of API. Now it's overcomplicated, and I don't know like how to use all of this shit. So what the fuck is that even? Do I okay, I can allocate a work list. Okay, so why do I have to allocate it? I have no idea, honestly. But apparently I have to allocate it. So yeah. Okay. So are you happy now? Are you gonna be okay? Look at that. Holy shit! It's a miracle. By randomly doing different things that don't make any fucking sense, we figured out how to create an object file with an external symbol underscore star. By using some outdated examples in issues, in pull requests, by stitching things together because nothing is documented. But again, the project isn't finished. I'm not blaming the project for that. I'm not blaming the project for that. But at the same time, if it's like, if my project was at that specific state, I wouldn't go out of my way trying to integrate it to other projects, which are supposed to be production ready, like for example, Odin. By looking at all of these things, how is this thing ready for Odin? I don't really know. So, do we have any professional Odin developers in here, or people who work in terms of Odin? Does Odin use this thing as the main backend of itself? Right, because judging by the state of the project, it's really raw and unfeatured, which is fine, which is totally fine, but it's already trying to integrate into Odin. Odin is a LLVM, okay. So Odin does not use it as the main backend. No, it's still main. Ah, okay. So that explains it. That explains it. Because it like I'm having like a kind of a dissonance. I'm seeing the project in a raw and complete state, which again is totally fine. There is nothing wrong with that. And yet it is integrated into a big project that is like production project. Because as far as I know, Odin is used in like in serious projects. So, and it's just like what the fuck is going, how is that even possible? Now it makes sense, right? So it's just a sort of like an experiment. It's sort of an experiment, it's sort of like in the flow. So honestly, we also need to try to do the following thing. We need to try to link it into something. All right, so B out. I should have called it O file instead of out, but whatever. So we can try to now maybe link this entire thing into the final executable. So can we actually... All right, so, and we got a B, which if we take a look is not a dynamic executable, but it is executable nonetheless, and it's sec false, which is expected because the body of the function doesn't contain anything useful. All right, I finally managed to do what I wanted to do, right? So we managed to create an empty object, but now we managed to create an empty function at least. Right. Odin also has its own version of tb.h. Oh, okay. So they have like a... Okay. So their own copy. Does it have tb passes? Of course, it has tb passes. tb passes is no more, I'm sorry. It's deprecated. Why are you using deprecated API? And after that, people are asking me to try this language. It is using deprecated API over tilde backend. How is that a production? No, I'm not going to be checking Odin. Like, I mean, it's not even using the latest version of tilde. How? No, I'm not going to check. Anyways, so I wonder if we can like maybe do a syscall. Is that possible to create some sort of a syscall? So here we do return, but I want to be able to call exit. So let me see. Let me see. Let me see. tb inst set exit location. This is where the stop will be. tb inst stop. No. We have halt, exit, quit. Is there any interesting instruction? Cisco. So we can do syscall, motherflicker. So let's fucking go. So this is a start f data type. What the fuck is a data type? What the fuck is a data type? Okay. Ooh. Data type of what? I don't get it. A return type? Why is it? Okay. So why is it not called return type then? Excuse me? Fucking excuse me? Okay, so we're gonna assume that it's return type, and maybe in this case I'm gonna say, okay, this is gonna be void, I'm gonna just ignore whatever it is, right? So syscall number 60, I do remember that exit syscall is 60. How can I create the node though? tb node, all right. So does anybody remember, like it's tb inst something something, it was something integer, tb inst int, how do you create that? So there was some in examples, right? So let's take a look at, oh my god, why is it so slow? I already lost everything. So int, nah. Oh, whoa. This is what? Nah, it's a function. It's a function. It's a function. Inst sint. Yeah, but I mean, it accepts a function, right? So it accepts a function. So it's literal instruction. But how do you create a node? Can you do something like tb node? Int. If we take a look at the tb node, time to rewrite. So does anybody know? Chat, be useful one time, please. How the fuck do I do that? Okay, so there's something in here. So maybe that. You need to allocate an int in a function. All right, so maybe this is what I have to do. Maybe this is the thing. So sint, because that's what it feels like. That's what it feels like. But what's funny is that why do I even have to provide the type in here? Like, that's bizarre. And why I don't have to provide the type for floats? How does that make any fucking sense? Maybe because there's several kinds of sints. That's probably what it is. Right. So I feel like this is what we have to do, which also kind of implies that we have to do this graph thingy inside of the graph builder or something. But that doesn't make any fucking sense. Doesn't make any fucking sense, mate. Though we can just try. Let's just try. So if I try to do make, yeah, you can't fucking do that. That doesn't make any fucking sense. So that's stupid. That's fucking stupid. You have tb function. I do have tb function. Wait, so tb inst sint. So it's an immediate value. Well, okay, maybe we can try to do that. So let's go ahead and try to do that. I think I'm a little bit tired already. My brain doesn't work properly, so All right, so to be data type, let me find. So it's a tag. Let's say that is going to be 64. Right, so it's going to be 64 and it's going to be 60. And the function that we're using in here is start f. But I don't know why do I have to provide a function in here. That just doesn't make any fucking sense to me. Like, how does that make any fucking sense? But okay, sure. I can even call it something interesting, by the way. I can call it sys exit, and it's a tb node sys exit. All right, so we got this param count. We're gonna say that we're gonna have one parameter count, and let's create a bunch of tb. Oh, by the way, where is that example? Small working example. Yeah, I have working. Oh yeah, so it is how you do that. All right. So apparently I'm a little bit tired. So I'm just a little bit tired. I'm sorry. All right. So here's the thing, and in here we don't even. Yeah, this is fine. It's fine. So this is gonna be exit code, and I'm gonna just put 69 in here, and which means that I can just take a pointer to exit code and it will act sort of like an array anyway. Alright, so I think this is how we have to go about that. I might as well also just return I64, but again, let's ignore it. So that should be it. And also, that means we don't have to return afterwards. Alright, let's fucking go, it didn't work. So what's up with that? So incompatible data type. Fuck. Why didn't you like it? Mother flipper, 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 flipper, mother flipper. So what? Yeah. TB tie. Fug, как списта, how do I allocate? Why is it all freaking different now? So I brought the keys. Do I have to do now this kind of shit? Bing bang, walla walla bing bang, Okay, so that explains it. Fuck! Okay. So if I try to do something like this, it's fine. Okay. If I try to do something like this, it's not. Maybe you need the return. Maybe. Why? It's an exit. So is the control flow analysis not aware that the exits... Oh shit! It is not aware that the exit syscall is not returning or something. I'm swear to God it's something with the control flow analysis. How would it know? Hard code it? If exit code, if first parameter equals 60, you know, you know how you solve any problems by hard coding shit. It doesn't pick into syscalls. Why? Because it's unfinished. Okay. Okay, so hell yeah! Hell fucking yeah! Hell fucking yeah! We generated a working executable! Working executable with the minimum documentation, so the API completely fucking changed. Right, so thank you everyone who helped in the chat. Right, so that was actually, I would say this was collaborative effort, honestly. This was a collaborative effort. So yeah, still better than Lagrange, exactly. Still better than LLVM somehow. Still better than LLVM. So yeah, the project is unfinished, as they stated up front in the README. So we can't really blame it too much, right? we can't really blame too much. We can only point out, you know, some places to improve. Some sort of like a working simple example again. So maybe examples folder, which demonstrate how to create like a hello world executable would be kind of nice. Right. And obviously the whole code is sort of like in flux, right? So we even have an entire translation units that are outdated. Looking at you, irgen.c. This is an entire translation unit that is completely outdated. Completely. It calls to the functions that don't exist anymore or have a different signatures and stuff like that. And I suppose instead of it, you're supposed to use Gen 2, which is better. And I can see why, because at least it's compilable. Right. Have you looked into test folder? A test is kind of weird, honestly. I think big boy. What the fuck? I think these tests are literal C programs for the Quick itself, for the C compiler itself. But I don't see an example that just uses TB. Is there any examples that just use TB? Because here I feel like they're just tests for the C compiler. Yeah, there you go. So these are the tests for the C compiler. Right. So, but what if I want to make my own compiler? Maybe I just missed something. So there's also freestanding in here. I don't know. Right. And to be honest, maybe at that particular point of time, there's no point in having these kind of examples because even the API is sort of in the flux, right? So maybe it's not going to be useful in any way. But anyway, I respect the ambition of this project. I respect the end goal, right? So because, you know, LLVM is kind of a little bit overbloated, right? So a lot of projects try to use it, and that's usually what happens with popular projects. They get overbloated, and they get overbloated because a lot of other projects are using them and trying to add their own use case to the project, which hard codes a lot of things, and it slowly overbloats and stuff like that, right? So, and it's honestly, it's kind of a natural process, isn't it? Right. So the more projects use it, the more generic the project becomes. The more generic project becomes, the more bloated it needs to be. Right. It becomes like the everything project, essentially. So it's kind of natural for it to grow like that. Look at Linux, for instance. Right. It's a bloat, right? It's a several hundred of megabytes of just source code. Several hundred megabytes. It's dozens of millions lines of code. So Casey said that it's 13 million. I think right now it's even bigger. Right. So this is because everyone is trying to use Linux in all of these different use cases, and you have to support all of these use cases. Hundreds of megabytes of backdoors. Yeah. Hundreds of megabytes of backdoors. So yeah, that's an interesting project. It definitely deserves a star. It definitely deserves a star. Right. So, and I wish all the luck to the author to achieve their goal. Seriously, it's pretty cool. It was fun. It was a fun exploration. Really fun project. Great sense of humor. I really like the based flag. I really like the thing flag. So yeah, it's pretty funny. So really cool. All right. So thank you so much for the sub. 147 Chom 92. Thank you for the Twitch Prime. All right, I guess that's it for today. Thanks everyone who's watching me right now. Really appreciate that. Have a good one, and I see you all on the next recreation programming session with Mr. Azosian. So yeah, I love you all. Mwah.